Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday evening. This one happens to be June the 7th, 2019, 9 o'clock in the evening, Daylight Savings Time. For those of us here in the eastern portion of North America, Universal Time, that would put it 1 o'clock in the morning.
2 o'clock. Oh, yeah, 1 o'clock. Sorry,
1 o'clock in the morning, Universal Time, yep. June the 8th, Saturday morning. And what do we try to do on Friday nights, Nick?
We're going to take over the world.
Oh, that's right. Well, we'll do our best. At least take over the internet radio waves.
Good job, because in the chat room with you and me right now, Marty, is Optronics, Glenn, Evil Spock. Starstorm is on her way in.
Okay.
Let's see, what else? I have been asked to, however, very kindly by about 4 people, could I please post the YouTube link ASAP so that people in places like the Philippines and Korea who can't, it's a bit difficult to be with us, can actually have a listen to the show. And normally if it goes out to some of my Filipino friends, normally they're sharing it themselves, peer-to-peer kind of.
Mm-hmm.
So we may not actually see the numbers tick up for who's listening, but they do share the podcast. So that's always good to know.
Oh, something I was going to mention, I forgot to mention while we were talking with our radio director. I read something about iTunes might be going away.
What they're saying is you now got to get 3 different apps. A TV app, a podcast app, and a music app to replace the old iTunes.
Okay.
I get the feeling Apple's shooting itself in the foot.
Mm-hmm. Well, I think they're doing it right.
It's not cheap.
Yeah. Well, so I go to iTunes Radio all the time, and we have our broadcast on iTunes Radio. And I just wondered, is that going to go away? Is that going to change?
Yeah, it will change because, like I say, instead of just having iTunes on your computer, on your tablet,
as it like a website.
Well, no. It's basically, you've got to make sure you get the correct app.
Yeah.
So otherwise, you can't download podcasts. You can't watch any of the shows that you bought.
Mm-hmm.
Can't listen to the music you bought.
I don't use it for anything like that. I just listen to their free radio. That's all.
Well, I don't use them for free radio because I actually have a very nice little radio app that goes around the world. It asks me for the name of the radio station I want to add to the tuner, and then it hunts it down and puts it in for me, so I can just click on it. I can go to BBC Cymru, BBC Wales. I can go to, all kinds of stations all around the world.
Mm-hmm.
For the click of a button. If I tell it which country to look to, then I can scroll through a list of radio stations.
But are we in that? Because we are in iTunes under Talk Radio.
We're not on the app I use because we're not officially we're not a radio station that uses radio waves.
Right. All right, so we'll have to keep track of how much it goes away if they keep their free radio section that we are in. Hopefully, we'll find out.
They're scrapping iTunes totally.
Totally. Did you hear one? Last time I checked, it was still there a couple of days ago. So.
It was a couple of days ago. One of my radio amateur friends, Martin Butler, posted a warning on his podcast site saying, if you listen to download us via iTunes, you better start looking for the new apps because fairly shortly it's going to be gone. So every us that have got iTunes on our computers are going to have to find a way to our podcast somewhere else.
I'll keep checking. I wonder if that app will be available, the free radio part, or not. So, and if it will be free to get into it, or if I have to buy an iTunes app for too much money or something like that.
So far, I've heard that there's two versions. There's the free version, which means you're going to get slammed with ads, and there's the premium version. It has no ads. Except ads for Apple.
But you pay for it. All right. Well, we'll find out. Keep track of that. So keep checking. If you listen to us on iTunes, keep that in mind that iTunes itself might disappear. We might have to refind it.
It is disappearing. They are rebranding themselves. Everything's moving up market again, high prices.
Mm-hmm.
I
would say it's not necessarily disappearing. It's just changing.
No, iTunes is going, full stop.
Right, but they're going to go with something else to replace it, right?
Yeah, 3 apps.
3 apps, right. So that's what I'm saying. You have to find something to replace it.
They're not available on PC yet, and they're certainly not available on Android yet.
Okay.
Only on iOS.
All right. Something for us to think about, where other places we can be heard.
Well, as I say, we have a link that goes straight to our server for radio. Now you can use that. You can put that straight into a browser.
Mm-hmm. Mm-hmm.
And that will let you listen to us. You can save it as a regular place on your favorites.
Yeah. Website.
To listen to it. And just minimize the tab.
That's more of one of those things that if you know we're here, you can listen. But if you don't know, you won't find us just by, hitting a bunch of different radio stations and coming across this type of thing.
To be honest, Marty, if I want to listen to what AFM's putting out, all I do is go to this link in my browser. Simple as pie.
So that's if you want to listen to it, but it's not it's not a way of discovering us.
I think at the moment we're going to have to push the link through the AFM Facebook page, and just those. And all the Sky guys are going to have to push it through their Facebook pages and their stories. That way we can keep it going. We can get it out there. To be honest, some of my friends do it literally so they get the links off my Facebook page.
Right, because they already know about us. That's what I'm saying.
Because I'm forever talking about it and I'm forever posting the shows.
But people that don't know about us on Facebook won't be able to just find us there. Won't be able to know we're there because they won't be just checking different quote unquote Facebook pages and come across us like they do on when you have a whole list of radio stations like the iTunes radio had. You can just click on any one and see what it is. If you like it, fine. If you don't like it, you go away from it. But it's something that you could actually just kind of go through a list and start clicking on it and see what's there. So that's kind of what helps us get out there to people that don't know about us. People already know about us, they can find us. But people that don't know about us really need to have them a way of coming across us and discovering us.
Well, as I say, one very good way is that everybody who listens to us can talk about us, can give the link out to their friends if they want to listen, and that way it snowballs. It's kind of like an avalanche. You start off with a little small object that's rolling, and as more people give it out, the snowball, so to speak, gets bigger and bigger and bigger as it goes down the valley. It's the avalanche effect. It spreads out that way as well. So that's one way to do it.
That's one way you want it to do it, but not necessarily the way it actually happens.
Well, as I say,
there's a difference.
Eagle Spock is saying TuneIn is good. Yeah, I've got TuneIn. I use it to listen to the rugby when it's on the radio only.
All right. So TuneIn's another type of thing that where you can actually just basically try different radio stations and see what they are. Okay.
The one I use.
So maybe we can get us on TuneIn.
Yeah.
Do they have a talk? Do they have a talk radio section?
Let me pull up TuneIn this 1 second.
Maybe somebody listens to it regularly. They can let us know out there in chat. By the way, yes, sir. Don't forget our chat is open right now. Well, it's always open, but this is a good time to talk to us while we're talking to everybody that's listening in through the radio. You can go to our homepage, astronomy.fm, and then you can see where it says chat near the bottom. Click on that, and then type in a name, and you can actually ask us questions if you like to. Of course, this is our live programming, so we'll be here for the next hour watching our chat room for questions. And then we'll repeat this program every 4 hours for the next 24 hours. But usually we don't have the chat crowd in like that. And we're certainly not in 24 hours a day after our show. So.
Hey, guess what? I went to TuneIn onto their webpage, and I opened their search box. I put astronomy.fm, and guess what comes up? Us.
All right.
It comes up astronomy.fm, an amateur astronomy community.
That was in TuneIn?
That's in TuneIn.
All right. And is there a way of just without typing it, is there a way of just finding us?
Okay.
You know what I'm saying? So, look up like Talk Radio Science or Talk Radio Astronomy.
That's exactly what I'm doing right now.
All right. Sounds real good. While you're doing that, I'll talk about the sun just a little bit. No sunspots. The sunspots, the two big ones that were around a couple weeks ago, have faded away. The one was fading away as we were watching it, and there was another one following behind it. It has also faded away. There's a couple of active regions where those sunspots were, but they did not strengthen enough. The active regions are still there, but did not strengthen enough to become sunspots again. So back to being a blank sun. And it's just going to be hit and miss and whether the sun kicks out some more spots again. So keep an eye out, and we'll see if we can.
Hey, guess what, Marty?
What?
I typed in Talk Radio Astronomy. We're listed.
All right. So tune in, everybody. Check out TuneIn if you want to listen to us. Well, if you want to tell everybody, not the web page, but they can find us on TuneIn under Talk Radio Astronomy. Cool.
There you go. So the link's in the chat room. That's
a link to TuneIn. Okay, how about to us?
Us? Okay, I can do this.
Yep.
I have access to
TuneIn.
Friday.
Maybe at tunein.com/AFM or something like that, or Talk Radio, or.
There you go.
There we go. All right. Thank you.
And you can favorite it and share it too.
All right. Cool. Definitely have to check out. Tune in. By the way, these links that we're putting in our chat room, if you're just listening in, we will also put them into, we put them in our AFM Facebook page, correct?
No, what we actually do is we put them on the YouTube of the show, which is, the thing is, Facebook corrupts web links.
Right.
So what do I do? How do I get around this? Very simple. After the show, our radio director sends me a copy of the show. I turn it into a video for YouTube.
Audio only, I should say, video.
Audio only, yes. I do actually have a copy of UBS as a video, a proper video.
That's under British Guys, by the way.
Yeah, and we are going to get together finally this weekend, this Sunday, to record the show we were going to do last weekend.
Oh, great.
But the thing is, I actually do have a proper video of that show, courtesy of one of the co-hosts, Richie, and actually also recorded it as well. But as I say, so we could, I suppose, really, if we really wanted to, Marty, and we felt really brave, we could actually do the show and record it as a video, and I have to, and then I can just post that on YouTube as well. I'm sorry to hear that, Thomas. It's great to have you in tonight.
All right. We'll maybe do that sometime.
Yeah, that could be fun. You can see me doing a Marlene every now and again, having a sip of wine.
Proper attire required.
Oh, yeah. Okay, fine. I'll dig out my Starfleet uniform.
There you go.
Are you going to come dressed as a pirate, Marty?
Red shirt for you.
You got a red shirt? Wear it.
No, I said for you, red shirt.
No, I have Command Gold and Sans Blues.
Ah. All right. Another article on the sun, by the way. Let me pop that in here. How the Parker Solar Probe is hoping for results with the Parker Solar Probe. It's already launched. This is from the University of Michigan. They're hoping to use the solar probe to discover how is it that the outer corona of the sun is actually hotter than the sun itself. The surface of the sun's about 11,000 degrees. The corona gets like 1 million or 2 degrees hot, and they don't really know how that works. So they're thinking it's something to do with some magnetic fields that might be fluctuating up and down, because they think it's also spotty. Yeah, the corona has different temperatures in it, so some spots are hotter than other spots by quite a bit. So they're expecting to be able to figure out how the magnetic fields are traveling through the corona, and hopefully that will solve the mystery of why the corona is so much hotter than the surface of the sun itself. And there's an article. I put an article in our chat room from Science Daily, by the way.
Now, one of the things we were actually discussing before the show started is NASA has actually finally put on its commercial jacket. For a long, long time, NASA was very against commercializing the ISS.
Mm-hmm.
So it has now said that private astronauts would be permitted to travel to the ISS for up to 30 days traveling on US spacecraft.
Tourists.
So, space tourism. Kind of a bit behind the time, because Beardy Branson has already got ahead of them, even though it's only suborbital. He's actually started the whole shebang about space tourism.
Mm-hmm.
But where else to go when you've been everywhere else on the Earth than to actually go into low Earth orbit? So, what is the price tag for a night stay on the ISS?
Well, let's just say predicted preliminary price tag.
Well, the article says they've priced it at $35,000. That's £27,500 per night.
Mm-hmm.
That does not include your ride to the ISS, which most likely will either be via SpaceX or Blue Yonder, because at the moment the only people that are actually going to permit to do these operations in the US is SpaceX and Steve Bezos's Blue Yonder. So basically, you'll be traveling in a Dragon capsule or in one of the Blue Yonder capsules to the ISS. You'll spend 30 days there. You'll pay for the privilege, and it's probably going to cost you a couple of million for the actual flight. Now, keep in mind, you haven't even got there yet, and you've already forked out maybe 2 or 3 million. That's just for your seat.
Or more, yes.
Yeah, small fortune, as Starstorm points out.
Nothing for some.
But
yeah, well, there are a few people that probably wouldn't even miss the money, but never mind.
What's really important, though, Nick, does it include breakfast, that overnight stay?
Well, yeah, I'm assuming it does, and I hope it does, because at $35,000 a night, I'm hoping that it's going to be breakfast, lunch, and dinner.
That's minimal, though, so you never know what it's really including till you read the fine print. You never know till you get there.
Absolutely.
Hate to go up there and be stuck without breakfast.
Well, they've had a further caveat. There will be up to 2 short private astronaut missions per year. And that will be for a maximum of 30 days.
What I was thinking of, if they could, even like that flexible, expandable module.
Bigelow.
If they could send something like that outfitted as kind of a interesting hotel room. So this would be like your room on the space station. That would actually be pretty cool. They could attach a module to it. And if you're making enough money, you could do that. You attach a module to it just for the space tour. Spend your time in there. And it could be, outfitted obviously rather comfortably and interesting design and stuff like that. Make it even more attractive than just going up in the space station.
For about 1,000 years.
The average person
alone.
There's people that
Oh yeah, there's plenty of well-heeled people who wouldn't think twice about dropping a couple of million plus 35,000 a night.
Exactly. It already happens
in
in luxury yachts and stuff like that now, anyway. So.
Yeah, and if you go to certain countries, you probably are paying about 35,000 a night for the room.
Mm-hmm.
And that does not include food.
Top-end hotels, yes.
Top-end hotels, yes.
Do that.
But I'm not too sure I want to be in a Bigelow module because I'm not too sure about the sturdiness. And does that mean you have to sleep in a spacesuit because of the risk of a micrometeorite punching a hole in it?
Well, you get the same risk with the rest of it, man. We've already figured out that a small hole in something like that does not make it pop like a balloon, but it slowly leaks out, just like the one module that the Russians had. It had a hole in it. Now, was it about a quarter inch or something like that? Maybe. Well, they found out like it doesn't go pop and it doesn't go. It just leaks. The air pressure goes down, and they know that's happening. So a micrometeorite strike through, punching a small hole through, especially fabric, like I think it's like mostly Kevlar, would not be that life-threatening. Of course, unless you get hit by that particle.
True.
But the Kevlar would be more resistant to that. And obviously, if you're going to have like tourists, you probably want to make it a little extra thick. They could even close it up in between, stays and stuff like that. So it's got some potential.
Then of course, you've also got the thicker the material around you, the more risk from secondary and tertiary particles in space. The biggest issue, of course, is cosmic radiation, and when it hits metal, it sprays alpha, beta, and gamma particles. So that's another big thing is you've got to face is, okay, you're Mr. Multimillionaire or Mr. Multi-billionaire. You're in space. I hope you've had your kids already.
Now, what about the astronauts? They're getting zapped all the time too. Now, you said that's when it hits metal. How about just passing through fabric so you don't get the secondary radiation? I wonder what the calculations are for the amount of primary radiation versus the amount of secondary radiation. Which one has a worse effect on you? That'd be an interesting. I'm sure somebody's figured that out.
Oh yeah.
And obviously, there's got to be less cosmic rays than there is secondary cosmic rays.
Okay, so I've actually done a quick search on the inflatable Bigelow habitat.
Well, we'll get that. We'll get that next time.
Yeah. So Bigelow Aerospace revived the design for use in a number of potential civil and commercial applications. So looking at it, it was originally sent up there and inflated on May 28th of 2016. And I'm just trying to see if they have.
Is it still attached?
I believe it's still up there. They just don't use it.
I can't remember. Yeah. You could do stuff like in back in the 1970s where you had like all inflatable furniture. Now that'd be definitely a way of saving weight up there. Have inflatable chairs, inflatable bed, bring your blow up camping bed.
In the chat room, do they have bed bugs and charge you extra for them? Bigelow actually claims that the module provides radiation protection equivalent to and ballistic protection superior to the International Space Station.
That's possible.
2 solar arrays, 2 thermal radiator arrays for heat, 0G toilet for solid and liquids, semi-private berths. The wall thickness is about 0.4. It's about 18 inches thick, fully inflated.
Okay.
The exterior will also feature 4 large windows coated with a UV protection film.
All right.
It's made of 24 to 36. I'll put the link into chat.
Okay, sounds good. And Aquafew in our chat room says yes, the Bigelow module is still attached, so it's still up there. So I think that's got some potential there.
Yeah.
Plus, that kind of module, I don't know how the price of that module compares to the price of hard shell modules. So if the Bigelow's less expensive, then that also makes the whole thing a bit more affordable too.
Okay, so it's got super strong Kelvar that holds the shape.
Kevlar.
Corby therm material commonly used in the food packing industry. The innermost layer of foam in the inside of the module is Nomex cloth, a fireproof material that also protects the bladder from scuffs and scratches. This is down on the technology section. So it also has a layer of Vetracan along with Kevlar.
If it really gets, going, they could have different themes, have multiple Bigelow modules and have different themes. One could be like 70s. It could have like, shag carpeting on the walls and stuff like that.
You mean like Dumb and Dumber?
Is that what it was? I don't remember that.
They had shag carpet on their vehicle.
On the side of the vehicle or outside of it? That's right.
On the outside of the vehicle.
Yes.
So, like I say, they have the capacity to produce at least 2 B330 habitats and a couple of transit tugs and a docking node. And if they can secure the customers to pay for approximately half the launch cost of the system, the lease rate will be about 25 million for 1/3 of the station. That's 110 cubic meters or 3,900 cubic feet for a 60-day lease and a round-trip taxi seat to low Earth orbit on a SpaceX Dragon V2 was projected to be 26.5 million per seat. Now, this is back in 2014.
Okay.
This is 2014.
Yep.
So, as I say, there's some very interesting stuff. The layers are fashioned to break up particles of space debris and small meteorites that may hit the shell with speeds 7 times as fast as a bullet. And the outer layers protect multiple inner bladders made of a module that folds into the module's air. Also provides good insulation that can from temperatures that range from about 121 degrees Celsius, that's 250 Fahrenheit, to minus 128 Celsius, minus 200 Fahrenheit in the shade.
Got to read the fine print, though. There could be little, those extra charges for extras, like oxygen, water, stuff like that. Yeah, got to be, make sure it all checks out.
Anyway, it's, as I say, as of at the moment, it's really quiet. No one's actually said anything about what's happening. Is it going to go ahead? Is it still going to be used? But as I say, if they're going to have tourists to the space station twice a year, they're going to have to, I think you're right, they're going to have to produce enhanced versions. But they really do need to have an anchor customer to go forward with building and launching any systems below low Earth orbit. Beyond Earth orbit.
I bet you don't get a discount for booking in the off season either.
No. 2017, Bigelow and ULA, they were working to launch a B330 on the Vulcan launch vehicle after outfitting an Earth orbit. The B330 will be boosted to low lunar orbit by 2 further Vulcan ACES launches by the end of 2022 to serve as a lunar depot. Originally planned to be launched on an Atlas V, but ULA stated that the in development Vulcan rocket was the only launch vehicle suitable with the performance and fairing capacity to be carrying a module. The timeline may be aspirational, as ULA have indicated that Vulcan will transition to using ACES upper stage around 2024. Interestingly enough, 2016, August, Bigelow did negotiate an agreement with NASA to develop a full-size ground prototype deep space habitation based on the B330 rather, under the next phase of Next Space Technologies for Exploration Partnerships. It's called the Expandable Bigelow Advanced Station Enhancement, XBase, and they hope to test the module by attaching it to the ISS. So I suspect that was the module that they actually attached. All interesting stuff.
Yeah. All right, one quick article before our break here. Did you get a chance to look for or listen to the meteor shower this morning?
No, because I got up, got up, made coffee, got dressed, and went to work.
Yeah, it was kind of early, just before sunrise. One of the Taurids or Aries. Yeah, it was the Aritids, the constellation of Aries. Meteor shower was to be basically during the daytime today. I didn't look up a website to see if how much radio noise they recorded from it, but they said that you could like your method usually, tune into a distant radio station with an old style analog radio and listen for increased signal. Or you could also, just before sunrise, go out and while it's still mostly a little bit dark before sunrise and the constellation's up, and see if you can see some actual meteors. And they said it was supposed to be kind of a potentially a decent one, but definitely a daytime one. Didn't try. Yep, I was sleeping. And I think it was really foggy for us here, too.
Yeah, well, as I say, it was beautiful and sunny this morning.
Yeah, it was.
At 56.1 Fahrenheit.
Mm-hmm.
When I got up, as I say, but when I get up, I'm like, I can do this on automatic. I'm walking across the kitchen, half asleep. My eyes are probably still closed. Yep. I know where my coffee machine is. Push, and that is a case of I have 2 K-cups of Death Wish coffee. It's going to wake me up shortly. Mm-hmm. And then it's a stumble to the bathroom, and about 20 minutes later, I'm out checking the rain gauge. Then it's back in, sit down, eat. I've been scarily healthy at the moment. I'm eating yogurts. And then it's Death Wish coffee. Then I'm wired for work.
All right, let's do a little station identification. You're listening to the Event Horizon program here on Astronomy.fm radio, which you always have every Friday evening. And this one is broadcast Friday, June the 7th, 2019, about 9:30 in the evening for those of us here in the eastern portion of North America, Daylight Savings Time. Universal Time would put it on Saturday morning, June 8th, at about 1:30 in the morning. We still have about another half hour of live program. Don't forget, we got more programs coming up after the Event Horizon, so keep tuned in if you want to and listen into more programming. But we will repeat all of our programs every 4 hours for the next 24 hours. So, I want to say thanks, hi to everybody in our chat room too. Right now, we've got, of course, you and me. We've got Glenn, Evil Spock, Starstorm, and Aqua for you are in our chat room. And if anybody's got any questions, this is the time to ask them. We've had a few pop out there and comments, and anybody wants to put in their own astrophotography, links to their astrophotography pictures. We like that kind of stuff too. So glad you're all listening in, everybody, and glad you're participating in chat too.
Astronomers have directly detected newborn planets.
Newborn planets, yes.
Newborn planets. So this is in a star system 370 light years away, and infant planets forming together are shedding light on the early lives of Saturn and Jupiter in our own solar system. So there is an illustration of 2 gas giants, exoplanets orbiting the young star PDS 70. Now, PDS 70, it is an infant among stars. It's only about 5 million years old. Its planets are still in the process of forming. And now astronomers have actually caught that process in action. So Sebastian Leffert at the Leiden University in the Netherlands and colleagues report that new observations on June the 3rd in Nature Astronomy. So PDS 70 is so young, it actually hasn't ignited fusion in its core. Neither has its radiation chased away the dust and gas around it. Its protoplanetary disk is approximately 140 AUs wide, but there is a large 20 to 40 AU dust-free gap. Well, not all disk gaps come from planets, but in this case, it's pretty clear that planets have swept to clear a large region of the disk. In fact, the massive planet PDS 70b was directly imaged last year, orbiting inside the gap. So using the Very Large Telescope in Chile to watch the signature of the hydrogen gas flowing into the planet, what's more, they've discovered a similar gas flow into what they're calling another planet, PDS 70c. And Glenn's got a question in the chat room. As soon as I finish this, you can go to that. We'll go to that, Marty.
All right.
They're using a very different instrument to the one that was used to discover PDS-70b, the multi-unit spectroscopic explorer, or MUSE. The Very Large Telescope's adaptive optics system helped MUSE obtain crystal clear images of this faraway system. Each of the images pixels does double duty, not only noting the brightness in a given waveband, but also recording the spectrum of that light. Those hard-working sprakel pixels are known as spaxels, which is just fun to say, really. It's a spaxel. So anyway, Hayford and colleagues focused on an individual spectral line, the one emitted by hydrogen alpha, and they created an image only showing whatever was emitting that line. After removing the star from the image, 2 dots remain. One is exactly where the previous discovered PDS-70b should be. The other one is on the other side of the star at the outer edge of the disk gap. So 70b is the most definitive case for a protoplanet, which was not in. This is from Thane Curie of the Subaru Telescope National Astronomical Observatory of Japan, who was not involved in the study. The PDS-70c object looks like very encouraging. Hopefully, future studies will show clear evidence for orbital motion. Isn't it nice that we actually have this? We're actually imaging a proto-solar system the light's only taken 370. Let me go back to the top of the article because I want to make sure I give that figure right. Yeah, it's only 370 years old. But we're actually imaging a solar system in its beginnings. And it means, really, if we keep watching, then we actually may catch the moment the star actually ignites and begins fusion. That sounds fun. Now, Glenn had a question in the chat room.
Yes, I see that. The question is, can a moon orbit a moon? And yes, generally. Because, for instance, a Earth satellite obviously orbits our own moon. So, yeah, that's no problem. It's all about the dynamics of the sizes of each body. So, for instance, if there was a much larger object orbiting the moon, and then it would depend on how close it would get to the moon. So if it was closer to the moon, it would orbit with less problem. Farther from the moon, it would have issues with Earth's gravity. It's called a 3-body orbit, which is really difficult to do. So a lot of times a moon, or let's just say a third body, will orbit both of the 2 inner bodies. It happens with a lot of triple star systems, 2 stars close together, and then a third object orbits around both of them, basically around their barycenter. So it basically depends on the sizes of each object and the distances between them on how stable those orbits will be. So something really small going around the moon, our own moon, for instance, yeah, that's certainly possible. Something bigger and farther away from the moon would have issues with Earth's gravity, and it would disrupt it. And it could be doing figure eights and twirls and things like that too. So it just depends on the dynamics of spacing, orbits, and sizes. So, yeah, Glenn says, you know that some asteroids have moons around them. So yeah, it's naturally, yeah, you can have small bodies going around larger bodies, but not either one of them being really big. In fact, that asteroid that just flew by the Earth about a week ago, it was a double asteroid. So it was an asteroid with a moon around it that just flew by us about a week ago, something like that.
Okay, right. Since we're talking about exoplanets, moons and stuff, 2 teams of astronomers have announced the discovery of a Neptune-sized planet in an unexpected orbit, and 3 exocomets whizzing around nearby star Beta Pictoris. So, examining data from the Next Generation Transit Survey, they've discovered a planet where it shouldn't be. It's about 3 times the size of the Earth and 20 times the Earth's mass. This sub-Neptune zips around a star every 1.33 days, proximity that keeps its temperature at a searing 1,200 Kelvin, which is about 1,000 degrees Celsius. Based on the mass and average density, it's quite probably that the planet has a rocky core and a gaseous envelope. Dubbed NGTS-4b, it's the first to be discovered in the so-called Neptunian desert. Sometimes it's also called the sub-Saturn desert. So in contrast to a plethora of hot Jupiters found orbiting close to their host stars, exoplanet surveys have turned up a dearth of hot Neptunes. So now we have one. Now, theorists can explain the absence of close-in Neptunes if giant planets, even close in, form right where they are, rather than forming further out, then migrating inwards. Planets forming in situ would need to have a certain heft to survive so close to their host star, because the irradiation alone would whip away the gaseous envelope of atmosphere of a smaller Neptune-sized planet, leaving only a rocky core to be discovered.
Depends on how dynamic the star is, though, because obviously Venus doesn't have that issue, but it's not as close as this object is. So
it's certainly not as close as Mercury.
Right.
But as I say, the interesting thing about this is this sub-Neptune migrated to its current orbit relatively recently, less than about 1 million years ago. Now, the move could have happened after the star's more active youth, giving the planet a better chance of holding onto its atmosphere. Now, so they also found around Beta Pictoris 3 exocomets. This is actually confirming observations taken over the past 30 years. Only some 20 odd million years old, Beta Pic is in the young adult phase of starhood. It's still surrounded by a disk of dust and gas in which planets are forming. One of those is the young gas giant Beta Pictoris b, which was directly imaged in 2008 by the VLT in Chile. Now, using data on the star's brightness from the transiting exoplanet survey satellite TESS, Sebastian Zieber of the University of Innsbruck, Austria, and colleagues have traced out a 105-day-long light curve, revealing 3 distinctive dips indicating the comet's passage. The dips are asymmetric, not periodic, and the longest one lasts about 2 days. So we've kind of settled down and accepted that Oumuamua was an interstellar object. It came, it visited, and then it waved goodbye. Didn't stop long enough to really be worked on, but quite a few amateur astronomers did manage to get imaging on it.
Mm-hmm.
But actually finding exocomets, this is new. Now, the test data can't distinguish between big fluffy comets and small dense ones. But what the team wants to do is they want to monitor for future transits whilst taking simultaneous spectroscopic observations. Now, so the comets have been long suspected since about 1987. Observations detected changing chemical fingerprints around the star. Otherwise, more likewise, comets have been proposed to explain observations of 3 other stars monitored by the Kepler mission, including the famous Bouragin star. However, while Kepler was mostly gazing at older and more distant stars, TESS is looking at the nearest 200,000 stars. So we may actually catch much more exocomet-rich systems as it surveys through its list of stars. And there is a preprint available on Astro ARXIV. So the paper will appear in Astronomy and Astrophysics shortly.
Oh, good.
It's nice, isn't it, really?
Yeah. All right, let's see. A couple things. Let's see. Well, we're a little still far away from the June solstice, so we'll talk about that in a couple more weeks or so. Let's see some more NASA stuff. I had the article, but it wasn't from NASA. A ring or cloud of cool gas has recently been discovered around the Milky Way's supermassive black hole. So the hot gas, is pretty easy to detect because it's tens of millions of degrees or something like that, as it circles around a black hole, and it gets speed up, it collides, and it emits like a whole bunch of radio waves and X-rays and things like that. So not too hard to detect, but the bigger the better the equipment, the better for that. Now recently they've discovered some cooler gas a little farther out, circling around our Milky Way's black hole. And it was not quite. Now that's harder to detect because the temperature of that gas gets to be something like, was it 10,000 degrees or 10 million degrees or something like that? So it doesn't emit the hot radiation like the inner gas does. So a little bit more effort to find it, and they did find cool gas, around our Milky Way black hole. I can't find that article. Where is that? It's been in a couple of places, and I can't find it. I'll get it there. All right. You got something else for him while I'm looking for that link to that article?
Yeah, Jupiter is outstanding at opposition. Prime time Jupiter viewing kicks off this month when the planet reaches opposition on June the 10th. I'd actually had an article about D-Day in astronomy, but I can't find it right now.
Okay. Yeah, I saw that article too. I read it. It was about the moon phase during the time that some of the reports weren't quite matching up with what people looked up and found out what the moon was supposed to be about. But I found out what the issue was. See, during D-Day, they were having gliders go in. And they wanted them obviously getting there in the dark, but landing with some moonlight so you could actually see the ground a bit. And the report said they wanted part of the story goes they wanted a late moon. A late moon, which means the moon wouldn't actually rise for a while. But what somebody was trying to say, well, a really late moon would be, we wouldn't be able to see the ground that way with a late moon. But no, there was a misinterpretation, and it kind of got repeated. What the original, I think, general requested was a late full moon. And there's a difference. There's basically 3 days of the full moon. So a dead-on full moon, the moon rises when the sun sets. So basically, you go right from sunlight to moonlight. Before that, when it's almost full, but it kind of looks mostly full, the moon will rise before the sun sets. So it'll be up as soon as when the sun sets. It's already been up a little ways. A late full moon is usually about an hour later, if I'm not mistaken. So the sun will set, and then about an hour later, the full moon rises. Now that was the conditions that the general originally wanted, but somebody in an article left that part out. They just said a late moon, that they wanted a late moon, but no, it was misinterpreted. They wanted a late full moon, and I do believe it was a late full moon when they, on D-Day, June the 6th.
Okay, so I found a link on space.com, how astronomy helped D-Day invasion. What it's not, as you said, it's not a late rising moon. The moon actually rose before sunset on June the 5th and remained in the sky all night long. It didn't set until after sunrise, so it was reaching its brightest peak in the sky at about 1:19 a.m. near the time of the British Pegasus bridge assault, and just as the American airborne operations began. Now, obviously, there was two big goals, and that was the capture of two bridges. One was known as the Pegasus Bridge now, and one is the Horsa Bridge. So British forces managed to capture both in the early stages. But the other thing that was critical to the invasion, and this is where astronomy comes in, because it's linked to the tides. So what it was, they wanted a low. Let me just go back to this.
They wanted a low but rising tide. Low, so they could see the beach installation, defending installation, so they could destroy them, which they tried to do, but they only got a few of them. And they didn't want the land. Now, if you have a decreasing tide and a landing craft go there, the tide's only going to get lower and lower and lower as a landing craft are there, and they could actually get stuck because if they went too far up the beach. So they wanted a low rising tide, so when they got there, they could get rid of the beach defenses, and then the tide will come in, and the landing craft will basically be lifted off if they're actually on the beach, and then they could get back out.
So what it was, Group Commander Stagg and his team, which was under the orders of Eisenhower, determined that the desired tide only occurs around the time of new or full moon. So that left the Allies with 3 invasion day options, according to Olsen, during the 5th, 6th, or 7th.
Yep.
The initial target was the 5th, but bad weather forced a 1-day delay. And eventually, because there were just so many people already on board various ships and tank landing craft, etc., they decided that the weather conditions were good enough on the 6th. Also, what was in the favour of the Allies at that point was the Germans were under the impression that the Allies only attempted landings in perfect conditions. Well, June the 6th was not. It was really terrible conditions. But the thing that was in their favour was A, the moon, and B, the tides.
Yes.
So they had no choice. They had to go.
Right.
But the weather conditions actually played into the hands of the Allies, because the Germans had just been stood down from the most recent alert, and they were not expecting the Allies to attack at that particular moment. I'm going to point this out. If you want to watch a reasonable film about the whole thing, just watch The Longest Day, because most of the main characters portrayed by the big name actors were actually the real people there, because in the credits they list all the people and all the families that helped get the thing right. Even Rommel's widow assisted the filmmakers with things about her husband and everything else. So it is a fairly decent film. I will say that. You can get it in color now. My copy is in black and white, and I have the subtitles forced for French and German. But one of the things I'd like to say, it does actually play up the important role that the resistance played, and of course the fact that without astronomy and weather forecasting, the invasion would have been a shambles.
It would have been different.
It would have been a disaster.
Well, it might have been delayed a month, so it might not have been a disaster. It just might have been delayed a month or two. You never know. So definitely would have been different. Well,
if they'd have gone in perfect weather, personally, I believe that the casualties would have been higher on the Allies. But that's something we're never going to know, because they went in them. They decided to risk the weather. They had the moon. They had the tides, and it was better if they didn't go on the 5th, 6th, or 7th. They were going to have to wait until July for the next reoccurrence. So
it was what it was.
The rest is history. Yeah. Okay, we got slightly sidetracked there. We were going to go back to Jupiter.
All right, we go back to Jupiter.
Yeah. So anyway, primetime Jupiter viewing kicks off this month when the planet reaches opposition on the 10th. Okay, so over the past few weeks, Jupiter has glared seductively in the southeastern sky. Before going to bed, you could actually go out and look in its direction, and most people would be debating about taking out telescopes and binoculars. Most people didn't bother because it was still low for a really good look. Now, the nice thing is, if you use a pair of binoculars, you will see the Galilean moons.
I want to speak about how that's been hyped up a little bit. Have you heard the hype on that?
I haven't heard the hype on it.
The hype has been, because it's coming up on opposition within a few days. The almost like a giant Mars type of thing, that Jupiter will be so big you could see its moons with binoculars. Well, most of the time you could see its moons with binoculars anyways, but they're way overhyping being able to see Jupiter's moons with binoculars because of the opposition coming up in a few days.
One of the best views I ever had, believe it or not, was on the roof of the physics building at Harvard many, many years ago with Louis Serrato. We went down there for a lecture, and afterwards there were several telescopes. You could look one way out towards the coast, and you could actually see a baseball game in progress. But I got some really good views at that point. But It's nice. It's nice to have it back in the skies. Jupiter is currently in Ophiuchus this summer. It's moving westward in retrograde motion, and it remains low in the south around declination -22 throughout its current apparition, and that is from Stellarium.
Mm-hmm.
So and there is a nice little star chart that shows you where Jupiter is right now. You can see Antares, Scorpius, Sagittarius, parts of it, and that's facing southeast around 11 p.m. local time in early June.
Opposition, I think, is June the 10th, if I'm not mistaken.
Yeah, it is. Yeah.
A event with his Jupiter's moons is coming up on the 10th too. It's actually pretty cool. At about 8 o'clock Universal Time, June 10th. That puts it about 4 in the morning for us here in Eastern North America. Io, the first of the 4 Galilean moons, and its shadow will transit the face of Jupiter at the same time. In fact, according to what I've seen, it looks like Io will be superimposed over its shadow, which will be actually a little bit bigger than Io itself. So that'd be kind of really cool to look at Jupiter and see a moon circled by its shadow going across the face of Jupiter. That's at about 8 hours Universal Time, maybe a few minutes before. 8 hours Universal Time, and it'll be across the face of Jupiter for 2 more hours. And then the next day, June the 11th, something similar, but not quite superimposed. Second one, Europa will transit with its shadow, and they'll be about a minute apart. So I don't think that they will be overlapping like that, but they'll be like right next to each other. And that will be at 12 hours Universal Time, starting and ending at about 14:30-ish, 14:30 Universal Time on June the 11th. So that's some pretty cool stuff to see. A moon and its shadow transit at pretty much the same time. Let me see if there's one. Transit starts, and then shadow starts, and transit ends, shadow ends. Yeah, so they're going to stay in sync for the Europa also. So I've actually seen where a moon is past its shadow during opposition. And that's a pretty cool event to see. This information is on projectpluto.com. And if up in the title part there, you look for Jovian events, and then scroll down to the June 10th, 11th, and then 12th's got some stuff like that too. Where interesting features always happen with its moons right around opposition time. Unfortunately for me, that's and you, that's Monday morning at like 4 in the morning.
Well, one of the things I used to love doing many years ago was actually imaging the shadow of Jupiter's moons as they raced across the disk. I think somewhere I've got quite a few decent pictures of that. So maybe once I get settled and everything's sorted out, maybe I'll have a go at doing that again. I will certainly be going back to imaging the moon, and definitely going out for comets.
The shadow's not that hard to image going across the face of Jupiter either. So I've done it with a video pointing into my eyepiece, basically, and had a pretty successful time of it. All right, time for one. I wanted to end with this one article here. Let me find it. Let's see. Here we go. Let me put that into our chat room here. Here it comes. Here we go. Ancient supernova, they think, prompted human ancestors to walk upright. Now, this were obviously our very primitive, almost pre-human ancestors thought that basically they lived in tropical conditions, and they thought one way that they started walking upright was by when the tropical conditions start turning more into savanna. So basically they were becoming no more trees to climb, so they had to go across the savanna, and it's kind of hard to do that on all fours, but much easier to do standing upright. As the grasses get tall, they can stand up and look over the top of it for predators and stuff like that. So they thinking that there was some supernova activity that ionized the atmosphere and basically increased lightning strikes, which set the trees on fire and created more savanna land.
Oh, by the way, Marty, we were discussing supernovae last week, a little brighter than the sky. I remembered that what I was trying to remember. Eta Carina in the southern skies.
Gotcha.
When that goes, that is going to be spectacular.
Yep. All right, everybody. Time for us to head on out of here. So thanks for all tuning in, and we'll see you next week. Good night, all.
Captain Savage, read a beamer. We're ready to come home.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing. And all of a sudden, wham! Astronomy right between the eyes.